Welcome to the Real Python Podcast. This is episode 107. What goes into creating those enhanced error messages in the latest versions of Python? And how does the new peg parser help to pinpoint where errors have occurred? This week on the show, Pablo Galindo Salgado talks about the work that goes into creating these improvements. Pablo is a core CPython developer and is the release manager for Python versions 3.10 and 3.11. He also is serving his second term on the Python Steering Council. Pablo is pleasantly surprised by the positive feedback for the new error messages in Python 3.10. He shares some of the upcoming enhancements for Python 3.11. And we talk about how the new peg parser allows for greater context when defining errors and where they occur. We also talk about how he started contributing to CPython, and he shares some of his programming experiences while studying physics at university. This episode is brought to you by LinearB. Their free Worker B for pull requests Chrome extension gives your team context about your PRs so that they can pick it up and review it faster. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Pablo, welcome to the show.
Hey, thanks. Thanks for inviting me.
So you've been really busy with lots of different things going on. The first thing I wanted to talk about is congratulations on becoming a member of the Python Steering Council.
Oh, thank you. Thank you very much. It's been an honor to be serving the community for the second year in a row. And I'm very thankful for everyone that has put their confidence in me and the rest of the Steering Council.
Yeah, it's been interesting watching that sort of evolve over the last several years. I'm really liking the direction things are going. So you guys are steering things well.
Nice to hear. That means that everything that we have been wrong has passed inadvertently. Now we put a lot of effort on trying to be up to the task.
Let's start with kind of a little bit of a background. I know that you have a background in physics.
Yep.
Were you using any other languages before you started using Python in that research?
Yeah, I actually started using an algebraic, but now it has evolved to be like much more than that. I don't know if it even qualifies as a language, but let's call it like that. It was Wolfram Mathematica.
Oh, yeah. Okay.
Yeah. It's kind of like a competitor of MATLAB. It's in that ballpark. And I use a lot of C because like a lot of, and Fortran actually, Fortran 77. Forgot about that. Hopefully I don't need to touch it again at all. But yeah, so it turns out that in physics, especially Fortran actually is very common. And it's kind of like a self-replicating language because your advisor made their Fortran program in the 80s and now you need to maintain that thing or evolve it. So, and it's so weird because all these programs start with some kind of like log at the beginning of the file, like a poor man git that says everything that has changed. It's so weird.
These are all the commits to it.
Yeah, these are all the people that have suffered in this file, right? Like you can. There is a counter of number of hours spent in this file, and you just increase it.
All right, that's cool.
But yeah, C and C. So like mostly C. Let's say.
Okay. And are there different like flavors of C that are more popular for that, or just straight C?
No, it's normally C99. Like there is, especially in academia. I mean, nowadays it's changing a bit. Also, people have clearly steered into C++, and especially because the programming I used to do in my PhD was mainly to be run on supercomputers and things like that, and clusters. And in the day, they were like very restrictive on what you could run there, and especially because like they also need to check that your program is worth it. Let's say.
Okay.
Yeah, right. Because like every hour of those CPUs, there is like a team of people that you never meet that checks the code and says, "Yeah, your program is worth it to run on our cluster."
That's wild. That makes me think of the shared computers of like the 70s and so forth, and waiting with a stack of cards or something to load into them or something. Wow. Okay.
In our case, the joke is even, I think, a bit funnier because we used to submit things to a supercomputer in Spain called Mare Nostrum, which is in Barcelona, I think, if I remember correctly. But the funny thing is that the supercomputer is inside a chapel. So it's like the sacred supercomputer or something. Yeah, they reuse the chapel to hold the supercomputer.
Going to church to run some software.
Right. The sacred code. But yeah. So they were a bit restricted, and like they normally allow used to allow a lot of things, but normally it was like Fortran and C, and these people need to read your code anyway. But nowadays, I think they have even an icon installed by default, which is great, and they have used now very extensively Docker and whatnot. So things have changed a lot for the better, for sure. But in my time, it was just good old Fortran and C99.
That's interesting. And so, how many years would you say it's kind of been moving toward Python and Anaconda and those things?
In those places, I don't know when they switch over. I mean, they like academia moves slowly, so this has clearly been after Python has exploded in the kind of scientific and numerical realm outside, although obviously it's related. But I think in the past 5 years,
okay,
being pretty common. I've been since I moved, obviously it's been a while since I was doing any research. As now I moved to the industry. So I have the touch points I have is because my friends that are still doing research tell me about or they ask me to solve things, and then I need to log into these places and try to fix things, right? It's like when your father says, "Fix me my printer," but in academia version.
So there are other people previous colleagues that you were working with, and you're kind of giving them an assist here and there.
Yeah, exactly. Like fix my Python installation in my cluster, right? Or
wow.
I have this code that runs in Python 2, and I cannot use it anywhere anymore. And it's like, okay, let's fix it. But it's not the most glamorous work, but no. It's what friends do, right?
Yeah, tech support is never that glamorous. It should be.
Right.
What types of tools were you using in Python to do your relativity and black hole physics kind of studies? Like what kinds of libraries and things like that were you using?
Right. So yeah, just to also clarify a bit to give a big picture of this. Like I'm a theoretical physicist, so most of my work was I would like to say with pen and paper, but also with computers, but with more algebraic systems and things like that. So equations.
Okay.
But then there is a time when you hit some equations that you cannot do anything else than simulate them, and that's when I started to do the computing. And in that part, in particular, I think the most typical libraries I used at the time were obviously NumPy, Python a lot to reach the code written in C and C++ with other things, and a lot of PyCUDA, which is like the bindings for CUDA, which is this language to code graphics card by NVIDIA.
Yeah. Okay.
And now there is a lot of things. Every time I go to PyCon, there is a new super cool thing that I wish I had at the time regarding graphics card. But at the time, PyCUDA was the thing. It was not a good story. It took me hours just to install a version because you need to compile things and there's no wheels. Now I understand much better the situation, but at the time it was always a pain. But yeah, good times with those tools.
Yeah, cool. How did you get involved in Python as far as becoming a core Python developer? And then we could talk a little bit more about how you kind of took on the role of release manager.
Yeah, of course. I think this story is not super fashionable, but the way I did is because I saw something wrong in the documentation. I don't know what it was. Yeah, it was something super ridiculous. It was not even a cool bug in the documentation. It was some code example was missing an import. I think, and I submit a PR because it was outrageous. How is this missing an import in the official documentation? Now as a code developer, I look at the documentation and say, wow, that was the least bad problem, right? But I submitted a pull request, and I had a great experience. I mean, I was contributing to open source before, but I had a very cool experience there, and I don't know, I got immediately hooked into contributing, and then I used my previous experience with C. It's also different, the scientific C code than kind of like programming language C code. So it sounds like I should be there and roll, but no. It's very difficult. There is many skills that they differ on, right? So, but obviously it helps. So normally I tend to gravitate towards the more internal parts. Obviously now I'm fully immersed into that part of Python. But at the time, I got attracted by the more C parts, so modules written in C or the interpreter itself or things like that.
Nice. Yeah, it seems like your background would help. I would guess there needs to be lots of different backgrounds in this group of core developers.
Right.
And then why did you take on the role of release manager?
I normally like to see different ways of contributing to Python, not only because I think it's a fantastic way to learn and go out of your comfort zone, but also because it's different ways to help the community. In particular, the release manager role was a bit, I find it fitting because I was, and I still am, looking at what is called the Billboard fleet. So CPython has a brutal CI, let's call it that way, a brutal CI.
Okay.
Apart from the CI that we have in GitHub, we have all these specialized machines that are running different OSs, different compilers. It's kind of like the combination of things is ginormous. I normally keep an eye on that, and for a long time, many years, every time some of these things break, I go on fixing myself. And this is part of more or less, except the fixing part, but this is part of what the release manager has to do. They have to take into account that, these machines are happy and the release are because if any of these machines are failing or there is problems on particular places, the release cannot go. So this is one of the many responsibilities. And I say, well, I'm already doing these things, so why not doing the rest? I discovered that there is a huge amount of extra things that needs to be done, like release manager is probably, I don't know, it's clearly more it's a huge time commitment. So it's a commitment for 5 years, just to be clear.
Oh wow.
Because because it's not only like the cool release now, when you release Python 3.10, then you need to keep releasing security patches and like bug fix releases. And if you just add all of those together, it's 5 years of your life doing releases.
You can't just hit the launch date in October and peace out.
I wish. No. Yeah, it also has a substantial social part, let's say. I don't know if social is the word here, but like apart from kind of doing the releases themselves, which are obviously very time consuming, there is also, you have as a release manager the responsibility that the release is stable and everything works fine. So there is a lot of like also checking the backtracker and see that, and sometimes you need to push people to fix things or act as a, to solve some of the disagreements, or unfortunately sometimes you need to revert things that people have committed just because it's broken and we don't have time to fix it for a particular release. So there is also a lot of like social interaction, which is important. I think it's important to highlight that it's not only a technical job, right? Like you need people skills, let's call it that way, which is even more important probably than the technical one and more and harder, right? So
yeah. I think about that. It sounds like there's a lot of project manager kind of portion to it where, there's all these kind of interdependencies of different things, and then also just having to be the one watching all that, bug traffic and other things coming in. So yeah, it sounds pretty intense.
That's an excellent way to put it.
Yeah, cool. Were there other challenges that you didn't expect as a release manager that you kind of stumbled into?
Well, many of them. I think if I will have to select one in particular, let me think. One of the things I've been trying to do also is to demystify this a bit, and maybe show to people what it does. So I tried to, well, I did actually. I streamed 2 of the releases, so the final release and the first beta.
Yeah.
And I think it's been great. Like a lot of people like those things. But one of the things that happened is that we were also in the first beta of Python 3.10. We were also renaming the branch from master to main.
Yeah.
And boy, that broke everything. Like we even broke GitHub. Like we have 500 from the webpage. I don't know what went wrong, but we were freaking out of it because, like, the CPython repo was broken in some weird way. And that happened live. That was very funny. But yeah, I think that was the most unexpected thing I had to deal with, I would say.
Yeah,
And there
yeah.
is others, but I think that was quite funny.
Lots of
And
nervous laughter, I'm sure.
yeah. Also, it's recorded. Like before this happened, I say, wouldn't it be funny if now GitHub breaks and it broke?
Oh no.
Yeah, it's recorded.
It's too crazy. Yeah, the other release in October went a little smoother.
Yeah.
I watched some of that. Sort of, you guys made really very much a release party, almost how like an album comes out. It was pretty fun.
Right, nice. I'm very glad that you enjoy it.
Yeah. Are there things you kind of pointed out a lot of the challenges and a lot of the work that goes into it? What are some of the things that you really enjoy about being a release manager?
I think the like working with everyone. I mean, I work with everyone already as a release manager as part of the steering council, but this expose you to a different kind of way, more closely, certainly. Like when we work, my work in the steering council involves reading a lot of like what people think and making sure that every opinion is represented and that we gather all the feedback. But it's less personal because we sometimes interact with like pep author or something like that. But normally, the release manager, you are in the trenches. Let's say it that way. And it's been very interesting because like it exposed you to a different kind of conversation with your colleagues and contributors and even like third-party projects, right? Like because it turns out that many people are affected by these releases, and sometimes it's not the most pleasant experience, but most of the time it is. So I think the thing I enjoy the most, apart from obviously the impact, right? Like you're releasing what now is the most popular programming languages.
Yeah.
Which is a very important responsibility, but also is very rewarding. But I think if I have to choose one, I will choose interacting more with people. I really enjoy working with all my fellow core developers. They're fantastic people, all of them, and everyone in a different way. So that's been a very good experience. And also, if I have to highlight as well, I would like to say also my interaction with the rest of the release management team. So Łukasz, Ned, Steve, and everyone else, they've been super helpful. And, we spend many hours together fixing releases. And yeah, so I would like to do a shout out to them. They've been really great.
Yeah, it's been kind of wild watching it. I've interviewed Łukasz twice now, and he was talking about at the time, sort of handing the reins over to you. And the fact that it's this yearly schedule now kind of sped up and definitely it's now yearly for at least the two versions that you're putting out too.
Right.
I'm guessing that you guys have somebody already lined up eventually for the 3.12 or what have you.
Yeah. And also, like, even this patch version, like, without going too far, like, literally this week we have released three bug fixes releases for 3.7, 3.8, 3.9, and 3.10.
Wow, yeah.
Yeah, some ridiculous amount of security fixes, and we have to do it twice because we found a problem mid-release, so we have to respin the whole thing and hold hold your beer because we may need to do another one on Monday. Yeah. So it's a lot of work. It's a lot of work. Yeah. So normally it's a lot of invisible work because people don't see all this restart of the release that take hours. But yeah.
Well, and I think about all the infrastructure behind there. I would imagine you've become a bit more of an expert of CI/CD than you ever thought you would be.
Yeah, no, I know. Indeed, yeah, I would say that, yeah. And also, like, to know all the PSF machines and infrastructure, and it's quite, I mean, it has evolved, let's say, organically. That's the word for chaotic, but
yeah, sure.
So, there is a lot of things to improve, and it's also like tradition that the next release manager improves things a bit. My improvement has been trying to automate part of the release, the part that is most automatable. There is part that is very difficult to do, like reproducible and stable way, but I more or less have a version that does most things for me and reminds me of the things that I need to do manually, like sending emails and whatnot.
Yeah.
But yeah, there is still a lot of like, trivia and arcane involved.
Did you know that the average pull request sits idle for 4 days without review? LinearB is here to help get your code merged faster with their free Worker B for pull requests Chrome extension. It gives your team context about your PRs and estimated time to review so that they can pick it up and review it sooner, letting you merge faster. Get Worker Bee free at linearb.io/realpython. That's linearb.io/realpython. One of the main reasons I really wanted to have you come on the show is to talk about all the enhancements that you've been working along with several other core developers, but adding these enhanced error messages in 3.10 and now also in 3.11. I kind of wanted to just think about like, okay, well, why were you interested in taking on that challenge? Like what are the motivations for adding some of these?
So, right, that's a fantastic question. So I think if I remember correctly, what was the genesis of the whole thing? I think it was that someone complained on Twitter that like, oh, like CPython doesn't do a great job like in this particular case, and that's bad. And I say, well, I mean, let me fix that. And that was not even related to the parser. That was related to the tokenizer. It was quite hard actually because the parser and the parser now is quite modern after we did the PEG parser, but the tokenizer and a bit of the whole architecture around that was the first part that we made for Python. It's the oldest checkout in the tree. I mean, obviously, it's not that it's bad or anything, but like it's clearly been updated much less. So and it's very how to say it's crafted in a way that is very specific for the original purpose. Extending it is quite challenging, so because it was not made into a general purpose like tokenizer, for instance. It's very tailored for Python. So adding some of these improvements is very challenging. Like for instance, for our listeners to understand one example. So this particular example that I'm talking about was the fact that if you don't close a parenthesis or a bracket or something like that, the error was surreal. It was surreal because the parser and the tokenizer are still trying to understand what's going on because you don't close your parentheses, but then you have more program after that, right? And then the parser is trying to make sense of that extra part of the program. Obviously, it doesn't make any sense, but it may happen that some of that may be syntactically correct or not.
Right.
And what normally happens is that you get some surreal error, like a function definition is wrong. And then you look at the line, I said like, this is wrong. And you look, no, it's not wrong. It's just def foo. How can that be wrong? And so the problem is that in those cases, the error, which is the unclosed parenthesis, needs to be like is detected afterwards. So it's not like, so you continue parsing, then you see that the parenthesis is not closed. Sometimes at the end of the file that normally show the this horrendous or this unexpected EOF or something like that. It's quite bad UX.
What's the F stand for there? I think of file.
End of the file.
It is, okay.
End of file.
Right.
There is another one which is less known, which is unexpected EOS, which is end of the string, but that is more difficult to find. But yeah, normally that happens because it's trying to consume more and more and more content because it doesn't find the closed parentheses, and then it just reaches another file and says, unexpected EOF when parsing or something. I don't know. I think every single beginner has searched that thing in Google at least once.
Yeah.
And the problem in this case is that you find out that something went wrong, but now you need to report an error that happens before, right? And that's very challenging because the Python tokenizer is constructed in a way that is very efficient for some things. So, for instance, the tokenizer doesn't consume more tokens if it doesn't need to, as opposed to tokenizing. Another approach will be tokenizing the whole file, right? To construct the whole file into token and then do the parsing. But the Python tokenizer only advances when it needs to, and that allows, for instance, that when you are in interactive mode, it shows the error even before you finish a full statement. So for instance, you have function definition and then you do something weird on the parameters. It doesn't wait until you write the body of the function. It will stop there and say, no, this is wrong already.
Right.
So it has another thing that it does, which is very annoying for this particular case, is that as it's consuming more and more text and producing it into tokens, it just throws whatever it has consumed away because it doesn't need to. Once it has produced the tokens from the text, it just throws the text away, like, line by line. So it sees a line, it transforms that line into tokens, and once it has finished, it just throws the line away because why you need that? But now it turns out that you need to use that line because you need to point to that line and say, hey, this parenthesis here was not closed. But that may be an arbitrary point in the past. So
okay. So it's lost its context. It has no idea, like,
Exactly. So now we need the most challenging way was doing it in a way that you don't need to redo the whole tokenizer to add these kind of backwards errors that we call. But that was done, and then what happened is that I showed this thing to people, and people were super excited. Like it was very surprising. Like I've been doing what I consider very exciting improvements in many parts of Python, right? Like new functions in the standard library.
Right.
I work a lot on the compiler. I work on the garbage collector. But this was like by far the most celebrated improvement. And I said, well, maybe there is something to do here, right? Like maybe people like this thing.
People in the trenches are like, yay!
Right. Yeah, like incredible. Like, and this was even before we tweet about this thing. When a lot of people really saw how much they like this. So after that, I say, well, we just finished with Guido and Lisandro's this work on the peg parsers, right? And one thing that happened since then as well is that a lot of people obviously are excited about what the peg parser allows us to do. It's been also an understandable also feeling in the community that now that we have this super powerful tool, and like big power requires big responsibility, but people are maybe thinking, oh, this is going to, now we're going to lose Python, right? Because now we're going to do this super crazy grammar, and people are like looking at the peg parser like a bit like the culprit of the problem, right? Like, oh, this damper parser now is going to allow to, which is just like a tool. So I thought like maybe I should use this parser as well for something that is celebrated, that we can only do with this, right? And because I was also on, like just finishing this other improvement, I say, okay, let's now use this parser to something like improvement in the error messages, because now we have this extremely powerful new tool that allows us to create error messages in a much better way, a much more reliable way. Because the old parser, the problem is that many of the, we can go into detail if you're interested here, but like the way you normally detect an error message is by creating a grammar rule that catches the error message. So you basically need to teach the parser to parse the incorrect Python expression, right? So you need to say, okay, if you see this kind of expression, which is incorrect Python, but try to identify it, and then you can emit an error. So that was in the old parser, it was very difficult to do that, not only because the infrastructure won't permit that, but because detecting these cases is it requires a much more powerful parsing. In technical terms, it's very difficult to have an LL1 grammar that allows to identify these particular cases. And the alternative was in one of the particular phases of parsing, which is when you construct the AST, the abstract syntax tree. That used to be a manual process, so it was handwritten code. It's basically transformer one tree into another. But and the problem is that you could add a lot of error messages in that particular handwritten code. But we are talking about I think it was a 8,000 line file, C file, done manually. Oh boy, maintaining that thing was horrendous, and the probability of messing things up or showing things wrong is so high, because in every function on that transformation you only have context for the particular node that you are parsing, but you don't have, when you're writing this code, you don't have the context of the actual language and the grammar. You just know that you are parsing a specific tree that can be in many places, right? Like, I don't know, imagine that you're in a function called parse addition.
Okay.
But addition can be done in an expression, in a loop, or like who knows. So, or a comma, parse element or parse item. But is that an item of a list comprehension, or is an item or a parameter? Because that changes a lot, right? In some of the cases, you can use stars for unpacking. In some others, you cannot. So it's very difficult to have the extra context. And it was impossible to add the error messages that you are adding right now, which are super complex in some cases. And now that we have the peg parser, now it's possible.
So I was wondering about that a little bit. Like, so in the case of a situation, you're kind of creating a much more complex, I'm thinking of like a dictionary, kind of doing spell checking. And this is way more complex than that, in the sense that you're kind of have like a situation with potentially an operator and then these other words that are around it. And inserting those kind of rules in that old file that you were just talking about was hard, because it, like, you potentially don't have the context of around it, or you'd have to like build like some specialized maybe portion of the tree to deal with those things. and then that's going to maybe mess up other situations. So I could see that it was just really
Right.
a hard problem to solve. So maybe we could talk a little bit about, how the peg parser kind of functions differently at a root level. I've talked about a little bit on the show that is being introduced in 3.10 or 3.9.
3.9 was the first version.
And kind of the idea that it can kind of look at expressions further, and it does a different take on it. But maybe if you're up for it, willing to talk a little bit about like how is the peg parser parsing expressions differently?
Yeah. Let me try. It's a fairly complex topic. So if someone is listening to this and say like I don't understand anything what's going on, so don't worry. I will do my best anyway. Normally, classically, when you create a parser, and in particular in Python, these parsers are automatically generated. So what we actually code is a parser generator that grabs a file that contains kind of like the formal expression of the grammar. So it's a file that explains what is correct Python.
Okay.
And we have, in both cases, the old one and the new one, we have a program that reads this file and produces code, that is C code that parses, which is the parser. So we don't write the actual parser by hand. Normally, when you do this automatically, as we used to do, and we do it now, or by hand, in any case, what you normally do is that you start with what is called a context-free grammar. Normally, in a version that is called Bacchus now form, it just have format, so don't worry about that. But like the way is that normally parsers are harder to write because the grammar normally is made into a way that is very easy to use it for generating valid programs, but it's very hard to recognize if a program is valid.
Okay.
And normally you don't only recognize if a program is valid, you also generate code out of the program or make sense out of the program. But it's more or less the same task for simplifying. Yeah, it's because like imagine that you have a description of what is a language. So for instance, you can say, okay, so you can have a production and the production can either be A or B. So if you want to generate random programs, you say, oh, it can be A or B. So I can throw a random number. Sometimes it's A, sometimes it's B, right? And if you have something more complex, so for instance, instead of A or B can be thing 1 and thing 2, and thing 1 can be A or B, and thing 2 can be B or C. So you kind of recurse into the tree and say, okay, I will throw random numbers, and sometimes I will pick A or B. So generating random programs is very easy from this, but generating the parsers is harder. So Peg kind of goes into a different way, which is instead of creating definition of the language that makes very easy to generate programs from it, but very hard to create parsers, let's do the opposite. Let's create a description where generating the parser is very easy, but kind of identifying, like generating programs is harder and other things are harder. And so conceptually, then the key definition, I think the way most people will understand the difference is the following. In a normal grammar, let's say this is a particular example. So you imagine that you have a rule in the grammar. Let's say that you have, for instance, I don't know, a statement.
Okay.
And a statement in Python can be a for loop, a class, maybe not the particular statement is not the particular best example here, but like imagine that you can have for loops or class definition or function definition or something, right? You can have many possibilities. And when the parser, imagine that the parser sees the word def.
Mm-hmm.
So the parser needs to distinguish if you are going to write a class definition, a function definition, a loop, or something else. But because the word def only happens to be on function definitions, then it needs a way to know, this has to be a function definition or is wrong. And the way it does it is that it deduces the correct version. So in particular, it has to distinguish if it's a class, function, loop, or something, and it uses math to know which one it is. It's a system which is, in particular Python, because it used to be a level 1 parser, it uses something called the first sets and the follow sets, which conceptually will teach you immediately from a token which of the possibilities are. So you see def, it knows that it has to be a function definition because function definitions all start with def and nothing else start with def, right? So that's how a normal parser will do. It will basically, when it's presented with many possibilities, it will use math to deduce the correct one. And it will always know which is the correct one. And if it's not any of the possibilities, then it will say invalid program. But Peg does something different. What PEG will do is that when it's presented with many possibilities, so imagine again function definition, classes, loops, etc., what it will do is that it will try one after the other. So it will say, okay, I don't care if functions all are the only possibility that start with the keyword def. I will try class definition, and it will say, okay, the first token of a class definition is class. Oh, but I have def. No, and then it's not a class definition. Then I will try a loop. Oh, but the first keyword of a loop is for. Oh, then it's not a loop. And then it will try a function definition, and it said, def functions also start with def. Good, good. Okay, let me see what is next. Foo. Oh, okay, foo is a name. That looks good. And it will continue, and then it will find out that actually it can parse the whole thing, and it will say, okay, this then is a function definition. So instead of like use math to deduce which one is the correct one, it will try one after the other until one of them parses.
Huh.
And that's the major difference between a PEG parser and any other parser in existence. Other parsers are different on how they deduce the correct one. So, LL1 parsers do it in a particular way because they are limited to only pick the next token. So when they are trying to decide which one is the correct rule, they are only allowed to look at the next token. But there are other more fancy parsers like, they have super weird names like LR parsers and LLK parsers and things like that. All of them super obscure. But the idea is that the difference between these parsers is how they deduce among many possibilities which is the correct one, obviously recursively, right? But PEG uses a different approach. It's literally, I'm going to try one after the other until one succeeds. And obviously, if you are into programming, you will immediately say, well, this is cool, but this approach is exponential because if you need to try all possibilities until you find the correct one, you're going to waste a lot of time trying the incorrect thing. If your grammar is very big, imagine Python, right? Like imagine that every time you see a token, you need to try the whole language. So it's not good. So there is a lot of extra techniques and quite advanced computer science to make sure that the actual time it takes to parse is linear.
Inefficient, yeah. Okay.
Right, yes, efficient. But conceptually, that's the main idea. The main idea is that it will basically try things in order. And obviously, as you can imagine, the fact that the parser fails to parse a particular rule is not a failure. It just means try something else. Meanwhile, in a normal parser, and particularly the LL1 parser, if the parser fails to parse a rule, means it's an incorrect program because it will use math to deduce which one it is. And if it fails, then it cannot be anything else because I know by my math that this rule is the only possibility. And if the rule doesn't parse, then there is no other possibility. While in a PEG parser, failure just means try the next one and hopefully it works.
So that helps you get back a lot of the context that allows you to kind of see some of the stuff around it because it's sort of holding in its mind, if you will, what it's looking for. Like it's like, okay, based on this, these are the things that are supposed to be kind of around it. Again, I'm talking so generally.
No, but it's a good guess. I mean, it's not a super technical definition, but it's a good idea. The technical term will be that a PEG parser has infinite lookahead.
Okay.
So a PEG parser obviously doesn't do lookaheads per se. I mean, at least in the same way an L1 parser will do lookaheads to distinguish which one it is. But if you kind of try to put them into a framework when you can compare both parsers, an L1 parser can only pick the next token, while a PEG parser behaves like if it's able to look infinite tokens ahead. So you can, the context that you are trying to mention here will be precisely this look ahead. So the PEG parser is able to say, imagine for instance that you are parsing, this is very interesting because this is actually one of the difficult ones. Imagine that you are parsing a function call, right?
Okay.
So a function call, imagine foo, a parenthesis that opens and a bunch of arguments. So the errors that can happen on a function call are much different than the errors that can happen, let's say, in a tuple expression. So, but both just differ on the fact that the function call is like a tuple with a name prepended, right? It's more or less the same because a tuple is parentheses with a bunch of things in between.
Right, inside of it, yeah, okay.
Right, and it's just that the function call has a name before, like the name of the function that you're calling. But from the parser point of view, it looks like name and a tuple, which obviously is invalid. It's invalid syntax. The only possibility here is that it's a function call. But in this particular case, you need all this extra context because if you are just looking, and this maybe is linking to the example that I put before, if you are in a function call parse thing between parentheses, well as used to be the old parser. Then if you find an error, how do you know if you're parsing a a function call or a tuple? You just know that this thing between parentheses. You just don't know which one it is, so you don't know if you need to solve this error or the other error. But a peg parser knows which one it is parsing, right? Because it has all this extra context. And I'm trying to hand wave a bunch of things, but it knows more.
No, that makes sense. Yeah.
It knows more about where it is and how it works. And we use this extra knowledge and this extra power. Sometimes it's more difficult. This particular example is one of the most difficult ones, because Python will first try to parse it precisely as a name and a tuple, and it will say, yeah, this makes no sense, and then it will try to parse it as a function definition. And the important thing for that to highlight here is that, as you can imagine, if it's going to try things one after the other until one succeeds, one interesting question that you can say is like, okay, what if two of them succeed? Well, the answer is that the first one that succeeds is the one that goes.
Okay.
That's how it works. So it's very important. The order is very important. So in a normal parser, if you say that this rule can either be an A or a B or a Z, it will use math to deduce which one is the correct one. So it doesn't matter that you say is a B, a C, or an A, or a B, a C, or a C, A, B, right? But in a peg parser, it absolutely matters. So this is a very tricky part of the peg parser. Like, you need to ensure that the order in which you put the options is the correct one for two things. One, so it doesn't try things that probably are not going to work early. And the other is that you may have two possibilities that work, and you need to ensure that the correct one, which is the valid Python, appears first. So you don't parse something that is not valid before.
Yeah, wow. It sounds like there's a whole bunch of kind of things kind of hiding in there that I think about, like, as far as the error messages that you're pulling out from that then. And what I wonder about, like, some of the things that you've been able to add through this method are not only the ability to earlier on determine that, okay, they were actually defining a function at that time, and that's why it's missing that parentheses or whatever.
Right.
But in a lot of cases, you're able to pinpoint, like, where the problem is, and you started to, in printing out, like, these messages back to the developer who is writing this program using these carrots, which I think is really kind of cool. And I don't know how new that is in a sense that, and I definitely see a lot more of it as you guys are continuing on, but you're kind of like underlining, if you will, in a way, kind of pointing to the spot where the error may be, or most likely is.
Yeah, it's a very good point, and it's a good observation. So I think it's new just because a lot of things fall into place. Like, we added in 3.10, we added let's call it the technology. We added the technology to be able to highlight whole ranges, and like not only one particular character where we think is wrong, but a bunch of them. So now that we had that, it was very natural to add to join that capability with the whole parser, not just to some parts of it. So we can not only pinpoint to where things are happening, but also entire sections. And we, as long as we were working on that, we also improved the how internally that works and how we propagate the information, so we can. But I think, wait a second, I think you are more or less. I may be mistaken here, because I'm discussing about like how the parser points to places, but I think you are talking about something else. You may be talking about runtime errors.
I'm talking about like the end result in some ways, like how the person seeing the error, being shown to them, and you're actually using these characters, these carrots or whatever whatever the symbol is, to point at the thing that's like right here, like this. You're missing something here.
Yeah, this is. I was thinking about, maybe you were referring to the fine grain error locations. That is something else that we work on, that we are super excited that will appear in 3.11.
Yeah. That's even fancier. Yeah. So I'm thinking about like some of the 3.10 stuff, like the missing comma, in like a collection literal.
Wow, that was so hard to do it right, because.
Oh, really?
Yeah. That was super hard. And this is very interesting because the reason error messages are normally very hard to do, not only in Python in general, is because it's not only like identifying if something is wrong is quite easy. I mean, as easy as doing a parser, right? So maybe not super easy, but like at least we know how to do it. But identifying what is wrong is very hard.
Yeah.
Because you need a lot of things, and sometimes it's not even possible. Sometimes you need the intent of the developer, right? We just know that there is a like in the sense that you need to now say, okay, if we are parsing this as a tuple, then there is a comma missing. But what if it's not a tuple? What if it's a function call? And what if it's I don't know, what if the user was trying to create a function definition? Or what if, so there is so many things. Like imagine that some user which is new trying to use square brackets to put the parameters in a function definition. So instead of doing def open parentheses, it does def open bracket. I don't know, because they come from some weird language, or they don't know.
Right, something else. Yeah.
So how, like, we will say, well, you cannot write a list here, but the user will say, a list here? No, I'm trying to do a function.
Right.
And so sometimes, a lot of times, you need to. We are only trying to add error messages when we are very, very sure that the error will be, with a high percentage of probability, will be very close to what the user was doing wrong. Because there is a lot of speculative proposals that a lot of people in the community have been doing. So I'm very grateful for that, right? So I'm very happy every time someone proposes new error messages. That helps a lot. But also sometimes unfortunately, we need to kind of reject those or don't go with those, because those can be actually ambiguous. Like it can be actually correct, it's pointing at an actual error and explain what is wrong in many cases, but in many other cases actually it's even more misleading. That's also why some of these errors say, perhaps you forgot a comma. They don't say you forgot a comma, right?
Yeah. You guys are very polite. The politeness I'm actually kind of enjoying. Did you perhaps mean this, kind of wording?
Yeah. It's more, I mean, we are trying to be polite, but I have to reveal that it's more on the fact that we may have failed, and then you say, no, actually I didn't forget that comma, right? You are totally wrong. But so that's why they do it in this tense, like, well, maybe this is the problem.
Right.
We are not super sure, but we try to add the ones that we are super sure. And the comma one, oh boy, the comma one was so hard, because in many cases it was not the comma, because the error, that's one very good example of what we've been talking before, because that particular error used to happen. The way we identify that error is when you have two names or two expressions together. So for instance, foo and bar. That is incorrect, because you cannot have two names together. That doesn't mean anything in Python. And we say, okay, every time we see two names together, it's very likely that the user is trying to put this thing on a collection, on a function definition or a function call, and it forgot the comma, right? Because if you add the comma, it makes sense. But it turns out that error was triggered in so many incorrect places when that was not the actual problem. Like maybe it was not in a function definition, so we have to change it into a way that requires more context. So this thing that we discussed about the context. So we started doing it into a way that even the old parser could have done it, because imagine that you're doing parse name, and then you pick the next one if you see that it's another name, like a variable name, and then you say, oh, error, maybe you forgot a comma. But now you need more things to know that actually you forgot a comma, because you need to say, okay, but are we trying, are we inside a list, for instance, or are we inside a tuple, or are we inside a function definition? If so, then yes, it's very likely that this user forgot a comma. But if we are not in those places, like imagine a for loop. Imagine you're doing for foo space bar. Did you forget a comma there? Well, very likely, but maybe not. Maybe you're trying to do something different. Maybe you forgot the in.
Yeah.
Right.
Yeah.
So it's not that clear. So so we have to add this extra context, and now we are only emitting that error if you are inside parentheses or some structure that looks like a collection or a function definition. So this is a good example of how you need all this extra context to not being annoying, because like being the hard part is not only to create the errors in a reliable way, but also to make them identify places when you're not going to probably mislead the person. Especially because, like if you are experienced, you may say, no, I know what I'm doing and this error is just bad. But a beginner may be even more frustrated if what the program is suggesting to them is literally incorrect. So they try to fix it into a way and it doesn't work, right?
Yeah, totally. Yeah, and I mean, in a similar fashion, like you have another example in the 310 documentation about if you're inside of a dictionary and you have Z and then space and then W or something like that, again, where you're saying, okay, well, what's the intent here? Like, I think you mean that you need a colon here, to identify this next thing.
Right.
But yeah, like you have to kind of like identify all these potential situations.
Yeah, that one also is very interesting. Maybe all of them are, right, but like that one is very interesting as well.
No, I think they are. Yeah,
Because you may say, okay, yeah. So you see the open bracket, and then you start trying to see if there is a colon. So it's very interesting because you need to distinguish if the user is trying to write a set or a dictionary. So you need at least one element. Like so you're going to trust the first element. If the first element doesn't have the colon, then what happens is that the user is trying to write a set and it added the colon or it added something else. So we know, okay, you are trying to write a set and you did it wrong. But if you add the colon, then we need to say, okay, this is actually a dictionary. So if we don't find the colon separating the key and the value, then we can say more confidently, oh, you are forgetting this colon because we are pretty sure you're trying to write a dictionary. But we need at least the first item. So if you write the error, like you forget the colon with just one item, we don't show anything just because we don't know. Yeah, right. So, yeah.
Yeah, and then as we kind of go a little bit further into it, you have like stuff for like identifying issues with, okay, you started a try block, but then you didn't get into the other portions of it of having either like an accept or a finally. And
right. That one also reminds me that one important thing in this project has been to collect those situations when it's very hard to understand what's going on, right? Or the error was bad, because it's very tempting to just imagine yourself the situation and say, oh yeah, this looks like a good candidate, and maybe it's actually very hard, and then you spend all this time and nobody is triggering that error ever. So working with people that are learning the language, and I work with many people that were starting to learn Python, and I ask in Twitter a bunch of times for educators and people that are teaching Python to collect all these cases, and then I had a big list. I prioritized them on how hard they will be to implement and how common they were, and I did some prioritization mechanism and I start to implement them as we go.
Okay.
So coming with those examples, that one that you mentioned with the try without the accept, that happened because someone that is teaching Python a lot, unfortunately I don't remember who he was, or she was, or they were. That came from because someone pointed that to us and say, oh, this is actually happening a lot, and then we say, okay, let us look into that.
This week, I want to shine a spotlight on another Real Python video course. If you're interested in enhancing your data science skills to make predictions from your datasets, this course can get you rolling. It's titled Starting with Linear Regression in Python. It's based on a Real Python article by Mirko Stojilkovic, and in the course, instructor Cesar Aguilar takes you through what linear regression is and what's it used for, how to implement linear regression in Python step by step. And not only do you learn how to set up simple linear regression, but also multiple linear and polynomial regression. You'll learn how to use methods from the scikit-learn library to assist you in the creation of your regressions. I think it's a worthy investment of your time to learn how to find the relationships among variables and use that knowledge to forecast and make predictions. Like most of the video courses on Real Python, the course is broken into easily consumable sections. You get code examples for the techniques shown, and all courses have a transcript including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. As you kind of go through these, it sounds like you kind of answered this question already a little bit, but you found out that some of these error messages that you kind of had a bit of a top list by surveying the community a little bit. Were there things that were like low-hanging fruit that you saw and said, okay, let's do these in 3.10, and then maybe you ran out of time and said, okay, right, these are the ones that I can get in under the wire? Because a lot of these are not specifically PEPs. They're being addressed through they're as BPO bugs.python.org, which is interesting to me because like I think of those like, okay, they're kind of an issue, but are you submitting that issue yourself or?
No, we are. All of them more or less. I think all of them have issues attached. Maybe there is some catch-all issue that catches a bunch of them, not individually. The reason is because there is people that actually care about these things, not only just because they know that they happen, because they could read the what's new.
Yeah.
but because they are doing libraries that rely on this thing. Like one good example is the author of Friendly and Friendly Traceback.
Yeah.
He's been super helpful, so shout out to him as well. Like he's been super helpful also trying to help us with suggestions or identify things that don't work. And he subscribes to every issue that I open regarding this because he needs to change Friendly on these error messages, right? Because it triggers even better errors in these cases. Because also think that doing this thing on interpreter is challenging because you cannot compromise like the speed of the interpreter just because you want the error messages, right? Like that's an important part, right? Like Python needs to still be as fast or even faster if your Python code is correct. And if it's incorrect, it cannot take 3 seconds just to show you that, oh, you forgot that comma here, because like that is horrendous experience. In other cases, like with third-party libraries, you may be able to do that not only because let's remember everyone that it needs to be coded in C if you are doing it in the interpreter itself, and many of these things are not easy to do it in C.
Okay.
Or at least they are much more complicated to evaluate that they are correct. So if you are doing it to a third-party library, you have the advantage of first being able to code it in Python, but also being able to take all the time that you want, just because, if someone is using this thing, is because they want to understand better the error messages, so they maybe want to pay the cost.
Right.
But in the interpreter, you may want people that don't care and they don't find acceptable that the parser takes three times more just because now has better error messages. So that's been also a challenge to.
I can imagine, yeah.
Right. So we have a lot of structure around that to ensure that this doesn't happen. Particularly, we do a first parse without error messages, and then if the program is wrong, we do a second parse with a more specialized version of the parser that tries to identify all these error messages. And we do even more stuff just to make sure that all the parsing, even with error messages activated, is fast.
Good. That sounds like one of those crucial things, because that's the other. Gosh, if if there was like a way for me to distill 100 episodes or so on the podcast, the speed of Python has been like the subject that is just always comes up.
Oh, right.
Kind of getting back to moving from 310 to 311, are there kind of a new set of error messages that you were interested in tackling?
Yeah, so in 311 we have in the world of error messages in general, we have a bunch more. So recently, actually, I'm just finishing the PR as we speak. Not right now. I'm 100% with you. But just today, I was working on that today. No, man. If I type, I have one of these mechanical keyboards. It will be horrendous if I start to type.
Okay.
No, I was working on that today. This will be better errors on function definitions, like things that can go wrong in function definitions. Things like, right now we have some like, if you put the double star before the star, we tell you that is not correct, or we were expecting on. But we have some contributors suggested a bunch of them, like things like, you added two times a star, right, for unpacking, and that is wrong. Or you added the slash of position only after the star, or you have you forgot, if you have a default argument, you forgot the default value, so you are hanging just the equal sign. Or like there is a ton of them, and well, maybe 20, maybe not. I mean, if someone thinks, oh, wow, 100 new errors. No, it's like 20 more, plus lambdas, right? Lambdas as well. But those are also new in 311. And I think at the beginning of 311, I also added like 10 of them as well in other places. So that's very exciting. So 311, we will have more. We don't backport them because, there may be something wrong and we don't want to compromise all versions.
Yeah, that makes sense. Yeah.
You need to wait until 311. But I think the biggest thing by far in 311 is PEF 657, which is this work that we did together with Batuhan and Amar, which is it's very non-glamorous. It's called include fine-grained error location in tracebacks, which sounds very technical. But the idea here is that we say this is not a parser improvement. This is a runtime improvement, and that is important. So the idea here was that many times when an exception is raised, we saw the line where the error happened.
Yeah.
But sometimes it's very hard to know exactly what's going on. Like imagine that you are adding a bunch of things, right? Like you're adding A plus B plus C plus D plus E or something like that. And a lot of variables. This happens a lot in scientific code precisely when you have a lot of heavy math. And then the error is you cannot add none with a string, or you cannot add none with integer. And you say, okay, which one of these variables is none? I mean, so it can be 6 of them, right? And you say, okay, I need to attach a debugger and like start looking around, and that is not good, right? Like,
yeah, you're deep into debugger at that point, right?
right, exactly. And then you need to reproduce the thing. What happens if now it's super difficult to reproduce the thing because it just happened with some weird message that you receive into your web server? Like, who knows, right? So it may be very difficult to trigger again. And or what happens sometimes, this is also very common, you have like a nested dictionary, like many dictionaries inside dictionaries, JSON for example, right?
Okay.
And then you are using you are accessing a bunch of keys. So the first level you're accessing key A, and in the second level key B, so you have a bunch of square brackets one after the other. And then it tells you, oh, none doesn't have a get item, because you cannot get the key on none. This means that one of the dictionaries that you expected it to be a dictionary is not a dictionary, is none. But which one? Like which level is the incorrect one, right? So good luck.
Yeah, how deep did it go?
Right. And even if you attach a debugger, if that thing is huge, well, identifying which one is not that easy, right? I mean, obviously, if you repeat the operation, is very easy. But if just by looking at it, it may not be easy, right? So you may need to, again, trigger. So the idea was here that we may be able to attach to the interpreter and make the interpreter a bit smarter to have extra information, to record extra information on every operation. So the technical term here is that Python is a bytecode, well, CPython at least, is a bytecode machine, right? It just creates bytecodes, and then it has a big loop that it takes every instruction and it does something different depending on the instruction. So the idea here is that in every instruction that the compiler generates, so instructions are things like add two numbers or access this element in a list or call functions, things like that. So on every of these instructions, the idea is that we say, okay, what if we, because when we are parsing, we know the line number and the column number of every single what is called the AST tree. So every single, let's say, expression or construct that the Python language has, when we are parsing, we know that information. We know where it starts, where it ends, and what line number starts and what line number ends. The problem is that when the compiler generates these instructions, the add number call function, that information is lost because it's not needed until now, right? And we said, okay, what happened if we attach that information that we already know to every bytecode instruction? Obviously, this means that the bytecode is going to be a bit bigger. So PYC files, which are these cache files that Python generates just not to have to compile 2 times, are going to be a bit bigger because now there is this extra information. Not much, like we expect it to be very, very small amount of, like, I think, I don't remember the exact details, but I think we measure, it depends of course it depends on the program.
Okay.
Some programs will be bigger or smaller, but I think we measure less than 8% or something like that. And we are talking about files that are megabytes, so this is kilobytes. So not many cases people shouldn't care about this thing. But the idea is that we augment these code objects and this bytecode with these locations. So when your program raises an exception and says, okay, something went wrong, here is the traceback. And so we go and say, okay, what is the operation that failed? Or is this addition operation that failed? Okay, let me look where this operation, the line number and the column offsets of this operation. Oh, is this one. So now when we show you the line, we can also point to you with, like, we can underscore or highlight with some underline, like exactly what part of the line is the one wrong. So now you can know, okay, so now is this key the one that is wrong, or now you can know, now is these 2 numbers the one that are, and that's super cool because it happens with everything, right? It's not only adding numbers and key dictionaries. It may be like any operation that you can think, like function calls within function calls. We got it. I don't know, context managers that have 3 lines and maybe you forgot that there is something wrong on the start of the context manager. We have that. NumPy arrays that are doing super weird operations with matrix multiplication. We have it. So we cover absolutely everything that the interpreter can do, and we can show it. Sometimes it's not super useful because, you have a x equal expression, but obviously the only thing that can fail is the expression because x cannot fail. It's just a variable name. But in many other cases, it helps a lot. I mean, like, one thing that happened is that while we were developing this feature, once we have it in a way that more or less worked, but we were refining it, the fact that it was working was helping us developing it because it was pointing to a lot of problems that we had.
That's
no joking.
That's cool. That's nice when the thing you're developing starts to help you. That's cool.
Yeah, that was very cool.
Yeah, well, that stuff sounds super exciting, and tracebacks have always been a bit cryptic for a beginner, even someone coming to the language from a different language. and just understanding how to read them and having this additional highlighting, if you will, this underlining and pointing and so forth is, I think, going to be really, really crucial
Right.
for people trying to find some of these things. So that's great.
It has also some interesting improvements for other tools. For instance, IPython tries to do this thing with some libraries. I don't remember the name of them, but there is something like traceback context. I don't know, but it's kind of in a hacky way. Like, I mean, kudos to the authors. They do a very hard job to try to identify what is wrong, and most of the time they get it correct. But there is a lot of edge cases when it doesn't happen, just because you are trying to guess, like, the information is not there. So now that we are adding this extra information to the bytecode, we are also adding APIs for low-level tools like, IPython or coverage. Coverage is a very good example. For instance, imagine that you have something like an if expression. When you do x equal something, if something happen, else something else, but in the same line.
Okay.
Right? Like, imagine that you have something equal foo if bar, else other. And the problem of that is that, that is a conditional in one single line. So if you have maybe, let's say that foo is true, then because you have foo if bar, if bar is true, so you have foo if bar, else other. So because bar is true, then you're going to have foo. But if coverage will see that line, it will say, okay, this line is covered because all this happened in a line, and one option of the conditional was triggered. So coverage will tell you this line is covered. But it turns out that no, so only part of the line, because you are also forgetting that there is an else, and the else have something else, right? I mean, weird expression, but
right.
there is some part that is not covered, right? Because you are not covering the case when bar is false. So you need to now coverage can know that not the whole line was covered. It can know reliably. Again, there is a possibility of hacking around this thing or trying to work around, but now you can know 100% reliably that no, only the first part of this expression was covered. You are missing the else part of the expression. And now, and this is one example, right? Like, you have many examples when coverage will highlight the whole line as covered, but actually there is many possibilities that happen in the line when some part is just covered and some not. And now coverage, if they want, they will be able to only highlight part of the line.
Yeah.
I don't know exactly how they are computing the actual number, but now they will point exactly to the part of the line that is covered and the part that is not.
Like a completion bar or something.
Yeah, exactly. Yeah. Or I don't know how they are going to do that. It's probably under, yeah.
That's cool. If people haven't been following along and watching the updates and the progress and would like to get kind of up to speed on what's happening with 3.11, Ger-Arne Jelle, who's been on the show a couple times, has been starting to create this series of, instead of waiting until October and saying, okay, hey, what's new in 3.11, he's saying, here, up to now, this is what we have so far, and has a really detailed article, and it goes really well into a lot of these error messages. And so I'll have a link for that and people can check it out, but I think it might be a good resource to help if you're interested in learning more.
Oh yeah, absolutely. I bless it. Like, we have actually checked it out. We are very happy that this is actually being covered with such detail, and it's a fantastic resource. I 100% recommend it.
Yeah, cool. So I have these weekly questions I like to ask everybody, and the first one is, what are you excited about in the world of Python? And it could be a conference or an event or a package, what have you.
I particularly, I mean, it's a bit of self-promotion as well, but I'm particularly excited about the faster CPython project. I'm collaborating with Guido. Like, my employer, Bloomberg, actually is giving me 50% of my time to collaborate with Microsoft on this. So I'm very grateful. Shout out to Bloomberg.
Wow, that's great. And
I'm very excited because we are very focused and we are already yielding very interesting results, and we have very good ideas. So I don't know exactly if we will be able to match all the expectation around this, but there is a lot of momentum already. There is a lot of very smart people working on this. I'm obviously not talking about me here, but like, other people. I mean, people will judge, but like, I'm discussing about the rest of the team. And there is a lot of good ideas, and it's moving along, which I'm super excited, right? So that's probably one thing that keeps me very excited recently.
Are some of those things coming in 3.11?
Oh yeah, absolutely.
Okay, great.
Yeah, 311. 311 already we measure. I mean, it depends a lot how you measure things, but like in the official benchmark that we have, the geometric mean, which is more or less an aggregation of all the different benchmarks, is already 20% faster.
Good.
Which is good, because before maybe we say, oh, CPython is 10% faster on this very specific thing, and only under this, the fine print is is very long. But now we can say confidently, well, it's 20% faster overall, which is, I mean, maybe it sounds a bit lame, but 20% faster is not easy in a language as old as Python and as dynamic as Python. So we are quite excited.
Yeah, it's nice to see improvements already kind of coming through, because again, that project is not that old. A lot of it was laying the groundwork. I'm guessing with the peg parser has helped with that immensely also.
Right, and in some parts, yes. In some others, it's just a different area. Like most of these improvements are in the compiler and the what is called the virtual machine, which I know a lot of people confuse with actual virtual machines and Docker. But normally, the interpreter itself normally is referred as a virtual machine, just because the bytecode interpreter and all those things actually simulate a machine, like how the CPU works. So this is called the virtual machine. So all of these improvements are in the virtual machine. And also, it's very interesting to highlight very shortly as well that this is not only challenging because it's a hard thing to do and find improvements and things like that, but it's also hard to do in a way that doesn't break third-party packages.
Yeah.
Right. Because it turns out that we expose a lot of things. This means that a lot of people can call a C code that the interpreter uses for specific things, and some of those are super specific. And it turns out that when you try to make them faster, you can break them. And also, it turns out that many tools are actually using implementation details of the interpreter that are not even fully officially exposed, like for instance Python or even profilers. But it turns out that even if those people know what they are doing and know that they are in not super clear territory, it turns out that we cannot release 3.11 and know that Python is going to be broken, right?
Yeah.
Even if it's on this weird line. So it's a very challenging thing, because many of the cool things that we want to do, well, it's not that we are not smart enough to not do them, or we are not trying to put our best effort into that. But it turns out that many of these things are hard because we need to do them in a way that doesn't break people, and some of them are just impossible because it will break so many people that what is the point that we have a 311 that is 40% faster if you cannot use NumPy?
Right.
Not acceptable, right?
Yeah, so you would hope that through the process of having alpha releases and even beta releases, that all the different package maintainers and open source projects are kind of paying attention to that. But I'm guessing that's can be depending on the amount of time they have to follow the schedule. I wonder if the yearly release schedule has affected that somewhat too. Yeah,
it helps. Right, it helps. We are also trying to be a bit proactive as well. Like the people in the Microsoft team, like Brand, for instance, is putting a lot of effort on also trying to, if we decide to break this kind of fine lines when it's not an obvious backwards incompatible change, it's just a change on a implementation detail that just happens to be used by a lot of people. We try to submit PRs to those projects and fix them.
Okay.
But obviously just to the most common ones. So Python, for instance, or NumPy, G-Event, things like that. So sometimes if you're doing a project that is relying on implementation details, so I mean, I'm very sorry, but that is you're not lucky. But we are at least trying to make sure that the big packages that are important, that are doing this not super legal things, let's say, they are not broken, right? So
yeah,
we try to do our best. Obviously, we will see. This is the first time we do a release since the project started, so this also makes my work as a release manager much harder, as you can imagine.
Yeah.
Hopefully, we have a nice story to tell here.
Yeah, good. So the next one is, what's something you want to learn next? And it doesn't have to be Python specific.
Or programming specific?
No, it can be whatever. What are you interested in learning next?
So I've been playing the guitar for a lot of years. like especially like the Spanish guitar and a bit of electrical. But I'm since the pandemic started, I'm very into learning electrical guitar again.
Oh, cool.
So I didn't start from zero, but so now my objective is learn to do sweep picking, which is a technique in the guitar which is notoriously annoying to learn.
Yeah.
Yeah, I don't go into details because maybe I will bore everyone. But like that's the thing. It's something that it requires a lot of practice, but also a lot of being a lot of practice and a lot of regular. I'm missing the word like
dexterity.
Yeah. Like when you need to be like very firm. Like I'm missing the word. What is the word? You need to do it every day, and
Yeah, definitely.
So I'm chasing that. Yeah.
Nice. What kind of guitar do you have?
I have it's quite a weird name. It's called a Variax Shuriken.
Okay.
So it's in this line. It's line 6, I think, is the brand.
Yeah.
And they have this line called Variax. The idea of these guitars is quite cool, actually. The idea of these guitars is that they, apart from the typical electronics of an electric guitar, they incorporate more stuff that is battery power that allows you to change the tone of the guitar.
Yeah.
So, for instance, you can make your guitar sound like a classical guitar, but it's still an electrical. But also, which I find, this is a lifesaver. It allows you to change the intonation of the guitar and the tuning. So, for instance, you can, without changing the actual pegs, you can change the tuning of the guitar from regular tuning to drop C or baritone. Like you can even go lower than what the instrument will physically allow. So right, which is super cool if you are like I'm very into rock and metal, and those genres normally require this 7 or 8 string guitar, which are like super low, and without one of those is literally impossible to play because the last the 6 string will be like an spaghetti, like it will be so soft that you will not be able to play.
Yeah.
But now with this I can, and the Shuriken is just a version. It's one of these guitars that is designed by some famous player, and they make a very limited run, but I really like the shape. It's like almost like a Shuriken. It's quite cool.
Okay.
Yeah.
I've been kind of eyeballing the Variax stuff and kind of wondering. Yeah.
Yeah, go for it. I'm super happy with it. I mean, they are not particularly cheap, but I'm super happy. They play like a dream.
Nice. I know that you had mentioned something in your upcoming PyCon talk about, even in our conversation today, that people have been submitting errors and things that might be of interest. But like, how would people be able to contribute to what you're doing there and adding new error messages?
Right. That's a very good question. So this is very interesting because it has two sides. I will go into more detail on the PyCon talk.
Okay.
But here, my focus has been on two things. One, trying to make it easy to suggest new error or add new error yourself. So I actually have added a new section in the Python dev guide. So I think it's devguide.python.org or something like that. If you Google Python dev guide,
okay,
developer guide, you will see. So there's a new section on the parser. So you check, there is something like the design of CPython parser. And it goes into, I wrote a huge document that goes into detail on like how the parser works, but also like how to change the grammar if you want. So even if it's not for error messages, maybe you want to change Python. So you can do it if you want. But at the end, there is a section on how error messages can be added. So that section hopefully will help a lot of people trying to grasp the basics of how they can add new error messages and how they can check that they work. So that's an idea. But on the other side, as we more or less briefly discussed, it's very tricky to add these errors in a way that is reliant enough. So the other part that I will try to cover, which unfortunately is more difficult to explain here, is how to make sure that your error, to identify what kind of errors will make the cut, because some of them are super exciting and a lot of people have suggested super exciting errors, but either they are not always correct or either they make other things fail, right? Like, because that is important. Remember that the peg parser, the order is important, and that the example I gave before is an example that is very simple. It's just ordering with two things, but like the grammar is huge. And turns out that changing a little thing over here can affect other things and can make other rules not parse. So that part is something that we will do in the review, so people don't need to be aware of those things. But the contributors need to be also like coming with some idea that it may be unfortunately not possible to implement, even if it seems correct, just because sometimes parsing is hard. And this has happened a bunch of times that, the error is good. It triggers all the times that need to be triggering, but sometimes it just makes some other rules fail. So we cannot add it. Both, I'm trying to make both things easier. One, trying to make people understand how they can add it, and also trying to tune people's expectations when they add new error messages.
Yeah, I think that's great. Having a decent set of expectations coming in is important, and hopefully we've set that level that this is not a super easy task where you're just adding that error in. There's a lot of reading through the syntax to get to where we're at. So
also, it's Python we were talking about, right? Like it's important to we cannot just there's so many people using this language, right? Again, it's one of the most popular languages now, and so we cannot. It's not even like the standards that a lot of people have in companies, which are very high. This is even higher because we need to make sure that we cannot just have just turn out this error, just make this part of Python incorrect. That would be horrendous, right? The bar is very high. So
yeah.
Fortunately, that leads to some stuff that we are not so sure not to pass. But I hope that people understand that doing things in the interpreter is probably the most complicated things, and the parts when we need to be more careful. So I hope that people understand that it's not that their code is not good enough; is that the bar is super high with this kit.
Yeah, definitely. So how can people follow along with the work that you do?
I have so they can go to my Twitter. I tend to tweet all the developments that we're doing, and when we put exciting things, it's Pablo Gisal, Piblogsal.
Okay.
And I did it right. But yeah, if they tweet Pablo Galindo Twitter Python, they have it.
I'll have a link for it too. Yeah.
Yeah, and also if you feel generous and you think that the work I'm doing is good, I have one of these GitHub sponsors pages when I normally try to also send some emails with summaries of what's going on and what I'm working on when there is enough momentum.
Okay, cool.
So yeah, if you are feeling generous, that would be another way.
Awesome. Well, thanks so much for coming on the show, Pablo. It's been really fantastic talking to you.
Yeah, the same. I have a super exciting time, and thank you for having me.
This episode was brought to you by LinearB. Their Worker B for pull requests Chrome extension gives your team context about your PRs and estimated time to review. Get it free at linearb.io/realpython. I want to thank Pablo Galindo Salgado for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.